8, one that many of you struggled with. It says, first thing, you have this carnival game where you're paying out this much at these probability levels, and it's lands a bucket. The carnival people have to pay that out. They are labeled. The player is given one ping pong ball, and if the player tosses it towards the buckets, if the ball lands and stays in a bucket, the player wins the amount the bucket is labeled with. The table shows the average probabilities for the player getting it into the buckets. It costs $2 a play. If 2,000 plays are made today, how much will the owners of the game pay out? Well, these are the payouts, 100, 50, 20, and 10, but at this probability. So we figure out the average payout by doing the expected value of the payout, which is $100 times 0.001 plus 50 times 0.008 plus 20 times 0.015 plus 10 times 0.05, which works out to be 0.110 cents plus 40 cents, I believe, plus 30 cents plus 50 cents, which is $1.30 is the average payout per play. Now, if they play for 2,000 times and they pay out on average $1.30, that works out to be $2,600. That's how much they're going to have to pay out. Now, what's the expected value per play for the owners? Well, we've been doing the owners. They expect to pay out $2,600, but for 2,000 plays, they're going to let's just continue here. They're going to pay out $1.30, but they get on per play $2. So $2 minus the $1.30 that they have to pay out is how much they're going to get on average income, which is 70 cents. Or I could have done all this and then added one more, minus $2 times one probability of 1, and you would have got this. So this is the expected value for the owner. They are expecting to make 70 cents a play. So C, how much will the owners make on 2,000 plays? Well, if they get 70 cents per play, 2,000 times the 70 cents per play is $1,400. Now, we could also have gotten this by saying, okay, 2,000 plays times $2 a play is $4,000. $4,000 coming in, $2,600 going out, means they're going to have $1,400 they're going to make. If you take $1,400 they're going to make and divide it by the number of plays, 2,000, you get the expected value per play. Okay? 9. 3 out of every 100,000 people live to be 110. And if there's, so we got this fraction, which is kind of a probability that they'll live to be 110, times how many people there are. 3 people out of 110 people. So there's no units left on this because the people cancel. This is just a probability, which has no units, times 315 million people comes out to be 5 zeros cancel 5 zeros, so we only have to do 3 times 3,150, and I think I can do that in my head. That's 9,450 people. There should be that many people that are 110 in the US if this is the true statistic. And 10. If there are 12 million bicyclists, each going 100 miles per biker. Bikers cancel, and we get how many miles they go, which is 1,200,000,000,000. That's how many miles are actually bicycled by the 12 million bicycles. And if there's 7,476 fatalities, for those, and I said get what's the fatality rate per 100,000 miles, so I have to have it in terms of miles per 1,200,000,000 miles biked. Then, and if we want to do it per 100,000, then we have to multiply by 100,000 to get it in 100,000 people. We get 5 zeros canceling. We get 7,476 divided by 1,2,0,0,0, which is 0.623 fatalities per mile, 100,000 miles. So half a person every 100,000, roughly one person for every 200,000 miles. Be interesting to know how that compares to driving.